Okay, what you should have out with you today is going to be obviously the notes, a sheet of paper, and you also need your steps out that I gave you a copy of for your regression. Okay? So I gave everybody their copy of their steps. Does everybody have them? Okay, so you need to have a sheet of paper, your notes, and your regression steps out. Okay, we have a test tomorrow over sections 2.2, 2.4, concept bite, and 2.5. The first thing I'm going to review with you is section 2-4, which is the concept bite for the piecewise functions. Okay, so I give you g of x. What's g of x the same thing as? F of x, which is the same thing as y. Do we all understand that? Okay. Now, when we did this, remember I said g at 2. I'm replacing the x in the original problem with the value 2. So we have to determine where does 2 fall in this lovely little range that they gave us. So is 2 going to be less than or equal to 3, or is 2 greater than 3? Which one is the true statement? It's less than or equal to it. So this is not an option, which implies that I'm going to be using negative 2/3 x plus 2. Does everybody have their calculator out also? Okay, you should have your calculator too. Now, the reason why I want you guys to have your calculator out is because many of you hate fractions. And I don't want you to be stressing about the calculation of the fraction. I want you to be stressing about what the actual answer is. So I'm going to plug in a 2 in this x. So I have negative 2/3 times 2 plus 2. If you type that into the calculator page, you are going to get your answer out immediately. Do we all understand that? What you're going to get, this is going to be negative 4/3 plus 6/3 to give you 2/3 as your final answer. Yes, I can do that in my head, but many of you cannot do that in your head. So if you cannot, I don't want you stressing about what you cannot do, but more importantly, what you can do procedurally, which is plug and chug here. Yes? Okay, going on to the next problem, g at 7. If I'm doing g at 7, what does that mean? Same exact concept as before. I need to figure out where does this 7 go in this region that they gave me. In other words, is 7 less than or equal to 3, or is 7 greater than or to 3? The true value is going to be 7 is greater than 3, which would mean that I'm going to be using the bottom portion of this function, which is x minus 2. In every place I see an x, what am I plugging in for it now? 7. So I have 7 take away 2. That gives me 5. Now, you remember, these were our answers, but I asked you to give them to me in a specific format. Do you remember what format I made you give them to me? In an ordered pair. So this ordered pair was going to be 7, 5. Yes? What was the original one, the first one over here? 2, 2/3. Remember, because you plug in x, and what do you get out? A y coordinate. Do we all understand that? Okay? One more to make sure that you all are with me on this. So scroll down, please. Tell me, what do I do? I need to figure out what part of this region 4 fits into. So is 4 going to be less than 2? Negative 2? Is 4 going to be between negative 2 and 5? Or is 4 between positive 5 and 20? So you tell me, where does it fit in? Which one of these is true? The first one is false, and this last one is false. The one that we're going to be using is our middle one. The value 4 is between negative 2 and 5. Would you all agree with me? So that means I'm going to be using the middle part of this graph, which is going to be the 4x plus the 1. And what am I putting in place of 4? Or I should say in place of the x is the value 4. So that's 4 times 4, which gives me plus 1, which gives me 17. Now, what ordered pair is that going to give me? Do we all understand that, and can you do that tomorrow? Perfection. Okay, that's section 2.4, concept bite piecewise functions. Now, let's scroll down to the next slide, please, on your laptop, and we're going to go to section 2-2 for review. Section 2-2, This is talking about direct variation. When you're talking about direct variation, what do you know about your b-value every time? Your b-value is 0. Excellent. Now, this says for each function, determine whether y varies directly with x. You know what that means? Tell me if it's direct variation, right? If so, find the constant term of variation. Huh? What's a constant term of variation? K, which equals y over x, what's another name for k? Slope, which is m, right? Do we all understand that? So what we need to do is we need to do our y over x. Why? Because that's our k value. And what's k? The same thing as our slope. Do we all understand that? Okay? So this is going to give me 8 divided by 2, and that gives me 4. If this is direct variation, then every one of those ordered pairs have to have exactly the same value, which is going to be what in this case? 4. So let's check. The next one gives me 12 divided by 3, which gives me 4. And the next one gives me 20 divided by 5, which is 4. Is this direct variation? Absolutely, this is direct variation. Okay? And if so, it says find the constant of variation. So what's that going to be? K is equal to 4. And lastly, it says write the function rule. What is a function rule? That's the equation of y equals kx. So my equation in this part is going to be y is equal to 4x. Do we all understand that? Yes or no? Okay. Next, still talking about direct variation. Does y vary directly with x? Yes or no? If yes, what is the constant of variation? So how do I determine if these vary directly? Solve them all for y first. Is this first example solved for y? Yes. And what is its b value? 1. If it's direct variation, what should it be? This has a 1, so therefore this is not direct variation. Do we understand that? Go to the next one. Is this solved for y? Solve it. So what do I do? Very good. So y is equal to negative 5x. Is this direct variation? Why is this direct variation? Because my b value is 0 because there's not a b value there. It's understood to be 0. So now it says if so, what is your constant of variation? K, which is negative 5. Do we all understand that? We golden? Excellent. Okay, the next thing, still direct variation. There was a lot of different scenarios in direct variation, wasn't there? It says solve knowing y varies directly with x. I don't understand. What does that mean? Y over x is equal to y over x. I need to set up my proportion, correct? I don't have points, though. How do I have points? Read it. If y is 5 when x is 8, that gives me the ordered pair 8, 5, doesn't it? And then find x when y is 2. So what's that give me? X, comma 2. So now I go right back to what we stated earlier. Y over x equals y over x. Do we understand that? How do I solve when a fraction equals a fraction? Cross multiply. So I'm going to have 5x is equal to 16. So x is equal to 16 over 5. Do we understand that? Yes? Excellent. Moving right along. Still direct variation. This says write and graph a direct variation equation that passes through each point. How do I write this equation? I need to still find k. K is still y over x. So what is y here? Negative 7 over 2. So what's my equation? How do I graph that? What do I start at? Nope. What do I always start at? I always start at 0, 0, and from there I go up 7 units and to the left 2. Bam. There's my graph. Do we see that? Okay, again, the next one. I have to still find k. So that's going to give me y over x, which is 13 over negative 8. Does it matter where the negative goes? It either goes the top or the bottom, just not both. So y is equal to negative 13 over 8x. There's my equation, my graph. I go 0, 0. I go up 13 and to the left 8. Bam. Do we understand that? Yes? Okay, and the last two things we want to talk about today, the last thing on direct variation is going to literally be a story problem. When we talk about direct variation, it is absolutely very easy to apply direct variation because we do it all the time with cooking. We're comparing two concepts and parts, it's talking about paint, okay? If we're going to do auto body, we're talking about, you know, the number, this much paint to this color paint, okay? If we're talking about hair color, same exact concept. This part of hair color to this part of hair color, okay? It's ratios through and through, okay? That's what we're doing here. So this says the amount of lemon juice in a lemonade recipe varies directly with the amount of water. In other words, it's direct variation. The recipe calls for 8 ounces of lemon juice and 32 ounces of water. Now, here's the beautiful thing about this. I can say that my X represents water and my Y represents juice. Brooke can say, no, she doesn't think like that. She wants her X to represent her juice and her Y to represent her water. Are we going to get the same answer? You will get exactly the same answer as long as you are consistent. Does that make sense? Okay? So our subjects here are going to be water and juice. What's H2O, y'all? Water. We already know that, yes? So my first ordered pair is going to be 32 ounces of water to 8 ounces of juice. And what's my second one? 28 ounces of water to Y ounces of juice. Do we all understand that, yes or no? So now I can find this. Y over X is going to give me, Y is going to be 8, X is 32, Y over 28. Can I reduce this? 8 over 32 reduces down to what? 1/4 is equal to Y over 28. Cross multiply or do simple concepts in your head. 4 times what gives you 28? 7, so therefore same concept here. 7 is equal to Y. 7 what? What does 7 represent? 7 ounces of juice. Do we all understand that? We good? Yes? Okay. That is the absolute last part of section 2-2. Now, I want everybody to grab their calculators, and we're going to do the last problem on the last worksheet that we did over section 2.5. And the reason why we're going to do that is because many of you are still very, very, very slow at regression. What am I going to do for you tomorrow? I'm going to allow you to use your worksheet, your steps. I'm going to allow you to use your steps. However, do not come up to me and say, Mrs. Yoder, I'm not sure how to do this. And what am I going to say? Use your steps, right? Okay? If you have a physical problem with the calculator, I will help you. But if you don't know what to do, don't ask me that. We all clear on that? So let's go ahead and get started on this problem. If you look at number 3 in your nice little worksheet, this is talking about a salary problem for what? Baseball players, right? And the directions say, the table shows the average salary S in millions of dollars for professional baseball players from 2001 to 2007. Complete a scatter plot on your graphing calculator. So, it says, letting T equal 1 represent what year? 2001. So what is 2001? What's 2002? 2003? Biggest issue right there. So everybody get out your graphing calculator, and we are going to do this together. I am going to give a new document here. And what type of new document do we want? Lists and spreadsheets. Click on cell A, and what do I label that as? Year. Click on cell B. Salary, and I will give you guys a minute. Next, do not enter anything where the equal sign is on that gray shaded row, right? We go to column A, row 1, and we start entering what? 1 through 7. 1 representing 2001 and 7 representing 2007. Do we all understand that? How do I get back to the top of my data? Control 7. I'm going to arrow over to column B, row 1, and I start entering in information there. 1.7, 1.8, 2.6, 2.5, 2.8, 3.8, 3.7. Please be certain that you've checked your data and that you've entered it in appropriately. Any typos will make a tremendous difference with your calculator, with your answers. Do we understand that? If you have a typo and you say, I did it right, I'm going to say you may have, but you didn't get the right equation. If you work at a bank and you put, make a $10,000 error because you added an extra 0, is that going to be an issue? Yes, so please be very cautious about what you enter in. Okay, so now I need to make a scatter plot. How do I do that? I'm going to go ahead and I'm going to do Control Doc. Am I okay here? I need to hit Enter and I need to get out of that cell, don't I? Because if I don't, it's going to say mismatched dimension. So hit Control Doc, add a new graphs page. What do I do? Talk to me. Hit Menu, Graph Entry, Scatter Plot. What's this going to be? This is year. It'll bold whenever it's ready. And it recognizes it. And then Y is going to be salary. Please, 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 on your steps right now. On your steps right now. Underneath, on step 7, where it says whatever you labeled be column B, please hit Enter. I did not put that on your steps because I thought it was logical and you all would understand that. But many of you are not hitting Enter, and it's really jacking with your problem. Okay? So please, hit Enter. Yes, it's logical to me, but apparently it's not logical to everybody. Okay? So hit Enter, and then you see it. But it's not a very nice view, is it? But from there, what would you consider? Is this going to be a linear regression? Is this a linear problem? Yes, it is. So letter A is going to be, does this represent linear? Yes, it does. Letter B then says, well, what type of correlation do you think this is going to have? It, to me, is positive because it's going uphill, and the dots all appear very close together. So a strong positive is what I would write. Watch very carefully, though. Menu, window zoom, zoom data. Does it still look like it's a strong positive? It does not. You know why? Look at the data. Look at the scaling. The scaling's from 0.4 to 4.01. Is this stretching it out big time? Yes, it's taking that window, which is a very normal window size, and it's going like this, and it's disconfiguring the data, the look of it, right? It's distorting it. Do we understand that? So it doesn't look like it's going to be a strong positive, but whenever we do our regression and we look at our R value, are we going to be able to determine that it's a strong positive then? Because the closer the R value is to 1, the stronger the correlation will be. Yes? Okay. So now I need to find my regression. So how do I go about doing that? Control Doc. Calculator. Stat calculations. And MX plus B. X list is year, your Y list is salary. And where does this always store it at? It always stores it in F1. Do we understand that? So hit OK. So at this point, we need to go ahead and we need to write our equation in here. So you tell me, folks. As we do this problem, what can you see and notice here? That you're going to have some decimal points that you're going to have to round to. So my equation was y is equal to 0. What was it? 3, 6, 4, 2x plus, what's my next one? Yes? Okay, now what is the r value? The r value is going to be 0.9543. Is that pretty close to 1? Yes. So is this confirming that it is a strong positive? It absolutely is confirming that. Now, how do I interpret the slope? What does this mean? Slope is the change in the y over the change in the x, so that's the change in the salary over the change in the year. What does that mean? My slope is 0.3642 over 1. So what does that mean in words? Every year. Okay, a yearly increase of salary of 0.3642 million. Right? Okay, what about my y-intercept? My y-intercept is the point 0b, which is going to be the point 0, 1.2429. What's x represent here? Year. What's y represent? Salary. So in your head, you need to be thinking year and salary. So this says in year 0. What's 0 represent? So in year 2000, the salary was how much? 1.2 million, right? 1.24 million. Yes? Do we understand that? Okay. Now let's go back to this. We didn't use all of our steps, did we? Now we go on the back side of our steps. And on the back side of our steps, it says to go back to page 1.2, which would be our graph page. And we actually need to graph our equation. So how do I go about doing that? I hit Menu, Graph Entry, Function. And that brings me to F2 immediately. So what do? Arrow up once and hit Enter to activate the function. Do we understand that? Because now I'm going to be doing predictions, and my predictions need to be found on that line, correct? So we go back to our questions, and our question on letter G says to do what? Use the model to find the average salary for the professional baseball player in 2010. So I give you what? I give you the year of 2010, which corresponds to what number in our data? If 0 is 2000, then 2010 is going to be 10. So all I have to do is on my calculator page type F1 of 10. And what does that give you if you type F1 at 10? So on my calculator page, I type F1 parenthesis 10 and hit Enter. What does that give you? 4.8857. In other words, how many millions of dollars are they going to make? 4.9, right? They're going to make about $4.9 million. That's how much a baseball player is going to make in 2010. Okay? Now, in what year will there be a professional baseball player that makes $6.3 million? Well, how do I find that out? I want the year, but I give you the salary. I don't know X, but I give you the salary of 6.3 million, right? So I go back to my graph. On my graph page, I hit what? Control T. And I need to scroll in there until I get to the value what? I need at least 6.3. So here's 6.3428. And what year was that? That was year 14. So year 14 corresponds to 2014. Do we understand that? That is the test. That's what you need to know for tomorrow. Questions, comments, or concerns? Okay, let me stop this. Test tomorrow.